Everything that has ever happened was caused by something else. The words you are reading right now exist because a person wrote them. That person exists because two other people existed before them. Those people exist because of a chain of biological events stretching back billions of years to the first self-replicating molecules in an ancient ocean. Those molecules exist because of chemistry. The chemistry exists because of physics. The physics exists because of the specific conditions of the early universe. And the early universe exists because of the Big Bang. Every link in that chain has a cause. Every event has a before. Every moment you can point to in the history of everything has something that came before it and made it possible. This is not just a feature of human experience. It is the deepest assumption embedded in science, in logic, in language itself. Causality. The rule that effects follow causes. The rule that nothing happens without a reason. The rule that every question of the form, "Why did this happen?" has an answer that points to something earlier. Now here's the question that breaks the rule. What caused the first thing? Not the Big Bang. Not the early universe. Not the conditions that produced the Big Bang. The actual first thing. The first event. The first moment. Whatever it was that happened before, which there was genuinely, absolutely, completely nothing. What caused that? The rule says every event has a cause, but the first event, by definition, cannot have one. A cause requires a before, and before the first event, there is no before. The first moment is the moment before which the concept of before does not apply. And if before does not apply, then cause does not apply. And if cause does not apply, then the most fundamental rule of existence, the rule that everything that happens, happens because something else made it happen, fails at the one place it matters most. This is not a puzzle waiting for a solution. It is something stranger. It is a place where the question itself may be the problem. Where asking what came first is not a request for information we haven't found yet. It is a grammatically correct sentence built from concepts that cease to have meaning at the boundary of existence. And that distinction between a question that is unanswered and a question that is malformed is the most unsettling thing this video is going to show you. Let's start with where most people think the beginning is, and why they are wrong. Most people, when they think about the beginning of the universe, think about the Big Bang. A moment approximately 13.8 billion years ago, when everything that exists exploded outward from an extraordinarily hot and dense initial state. The beginning, the origin, the moment before which there was nothing, and after which there was everything. This picture is not wrong exactly, but it is incomplete in a way that matters enormously for the question we are asking. Because the Big Bang, as most people imagine it, a clean, definite moment of creation, is not what the physics actually describes. The physics describes something more complicated and more honest. And the honest description moves the beginning much further back than most people realize, and then does something much stranger than simply moving it. Here is what the physics actually says. As you trace the history of the universe backwards, from now toward the Big Bang, the universe gets smaller, hotter, and denser. The galaxies come together. The stars dissolve into plasma. The atoms break apart into their constituent particles. The further back you go, the more extreme the conditions become. And the physics we have, general relativity for the large-scale structure of the universe, quantum mechanics for the behavior of particles at the smallest scales, describes this backward journey with extraordinary precision, up to a point. That point is called the Planck time. It is approximately 10 to the minus 43 seconds after the Big Bang. 1/10,000,000th of a trillionth of a trillionth of a trillionth of a second from the nominal beginning. A duration so brief that it makes every other small number in physics look large by comparison. Before the Planck time, in the conditions that existed earlier than this threshold. Something happens to the physics. The two great frameworks of modern physics, general relativity and quantum mechanics, begin to produce contradictions. The equations break down. The predictions become infinite in ways that signal not a real physical infinity, but a failure of the mathematical tools we are using. The physics does not describe what was happening before the Planck time, not because we haven't looked carefully enough, but because the frameworks we have were not built for conditions that extreme and genuinely cannot be extended there without producing nonsense. What this means is that the question, what happened at the very beginning, is not a question our current physics can answer. The beginning, the real beginning, the conditions before the Planck time, is not just unknown. It is currently beyond the reach of any physical description we possess. We do not have a theory of quantum gravity, a framework that successfully unifies general relativity and quantum mechanics. And until we do, the first fraction of a second of the universe's existence is genuinely, rigorously, and perhaps permanently inaccessible to our current tools. So when someone tells you the Big Bang was the beginning, they are telling you something that is approximately right, but precisely wrong. The Big Bang model describes the universe from the Planck time onward with extraordinary success. What it does not describe, what no current model describes, is what happened before, or at the Planck time itself. The real beginning, if there is one, is hidden behind a wall of physics we haven't built yet. But here is where the story takes a turn that is far stranger than simply admitting we don't know what happened first. Because some physicists have proposed that the question of what came before may not have an answer. Not because the answer is hidden, but because the question assumes something about the nature of time at the origin of the universe that may simply not be true. In the early 1980s, physicists Stephen Hawking and James Hartle proposed what they called the no-boundary condition, a model of the universe's origin that attempts to describe the quantum state of the universe at its beginning, using the tools of quantum cosmology. It is technically demanding and mathematically sophisticated, but its core implication can be stated in terms that require no physics background to feel the full weight of. In the Hartley-Hawking model, time near the Big Bang does not behave the way time behaves now. In the conditions of the very early universe, at the energies and densities that existed near the Planck time, the dimension we call time undergoes a transformation. It becomes, in the mathematical language of the model, imaginary. Not imaginary in the colloquial sense of fictional or invented. Imaginary in the precise mathematical sense. It acquires properties that are described by imaginary numbers, the square roots of negative quantities that appear throughout advanced physics and mathematics. What this means physically is subtle but profound. In the Hartley-Hawking model, time near the Big Bang gradually transforms into something that behaves more like a spatial dimension than a temporal one. The sharp distinction between time and space that we experience in the current universe, the distinction that makes before and after meaningful, dissolves near the origin. Time does not start at a point. It does not begin at a boundary. It fades. It gradually loses its temporal character and becomes something else. Hawking used an analogy that is worth sitting with. Think of the surface of the Earth. Now ask, what is south of the South Pole? The question sounds meaningful. It uses real words in a real order, but it refers to nothing. There is no location south of the South Pole, because south is defined as the direction toward the pole, and there is nowhere further in that direction. The question is not unanswered. It is malformed. It asks for something that the geometry of the Earth does not permit. The Hartley-Hawking no-boundary proposal suggests that what came before the Big Bang may be the same kind of question, not unanswered, malformed. Asking for a before in a region of spacetime where the temporal dimension has transformed into something that does not have a before. The question assumes that time extends backward through the Big Bang, the way it extends backward through any ordinary moment. The no-boundary proposal says it doesn't. That time near the Big Bang is not the kind of thing that has a further back. That the origin is not a boundary wall with something on the other side, but a smooth geometric feature, beyond which the concept of before loses its meaning the way south loses its meaning at the South Pole. This is not a comfortable conclusion. It is not an answer that satisfies the intuition that demands to know what was there before everything. It tells the intuition that the demand itself is built on an assumption that breaks down at the boundary of existence. That the framework you are using to ask the question, the framework of causality, of before and after, of events and their causes, is a framework that the universe assembled after the beginning and cannot be applied to the beginning itself. You are using time to ask about the origin of time. You are using causality to ask about the origin of causality. And the Hartley-Hawking proposal quietly suggests that this is exactly the kind of question that cannot have an answer. Not because the answer is missing, but because the question contains its own contradiction. Now, it is important to be honest about what the no-boundary proposal is and what it isn't. It is a serious, mathematically developed framework proposed by two of the most important physicists of the 20th century. It has been discussed, debated, extended, and challenged in the decades since it was proposed. It makes predictions about the state of the early universe that can, in principle, be compared with cosmological observations. It is not the only proposal for the quantum origin of the universe. There are alternatives, including the competing Vilenkin tunneling from nothing proposal, which suggests the universe appeared via quantum tunneling from a state of literally nothing, no space, no time, no laws. And the debate between these frameworks is ongoing and unresolved. What the no-boundary proposal is not is a proven description of what actually happened. Quantum cosmology is an extraordinarily difficult field, operating at the intersection of two theories that have never been successfully unified. The Hartle-Hawking wave function of the universe is a mathematical object whose physical interpretation is contested. Some physicists find the no-boundary proposal deeply compelling. Others find serious technical problems with it. The honest position, the one Cosmora always takes, is that this is a live and unresolved area of physics where the most we can say is that the question of the universe's origin is far stranger and far more conceptually demanding than the popular version of the Big Bang suggests. But here is what the no-boundary proposal does, regardless of whether it is the correct description of the universe's origin. It demonstrates that the question, what came before the Big Bang, is not necessarily a question that physics is obligated to answer, that there exist serious, mathematically coherent frameworks in which the question does not arise, in which the origin of the universe is not an event with a cause, but a geometric feature of spacetime that simply does not have a before in any physically meaningful sense. And that demonstration, that the question might be malformed rather than merely unanswered, is itself one of the most profound things physics has ever produced. It is the discovery that the boundary of existence is not a wall we cannot see past. It may be a place where the concept of past dissolves, which leaves us somewhere very quiet. The question, what was the first thing to ever happen, has been asked by every civilization that has ever existed. Every religion, every philosophy, every cosmology has proposed an answer. A creator, an eternal universe, a cosmic cycle with no beginning, a spontaneous quantum fluctuation. Each answer has the shape of a before, something that existed prior to the first thing and caused it, or permitted it, or preceded it in some sense. The no-boundary proposal does something none of those answers do. It does not provide a before. It removes the need for one. It says the universe did not begin because something caused it to begin. It says the the universe has a quantum state that simply does not include a boundary in the time direction, that the origin is not an event, it is a feature of geometry, and geometry does not require a cause. Whether that is satisfying depends on what you were hoping the answer would be. If you were hoping for a cause, for something that existed before everything and made everything possible, the no-boundary proposal offers nothing. If you were hoping for an honest engagement with the limits of what human concepts can reach, it offers something more valuable. It offers precision about where the question breaks down. If you are drawn to the places where human knowledge reaches its own boundary, where the most carefully built frameworks of science arrive at the edge of what frameworks can do, then Cosmora is exactly where that kind of honesty lives. Subscribe and stay. There are more boundaries ahead. But before we close, here is the thought that belongs to you now. Every question you have ever asked has assumed that the thing you are asking about exists inside a framework of time, before and after, cause and effect, earlier and later. That framework is so deeply embedded in the structure of human thought that it feels less like an assumption and more like the air you think in. But it is an assumption, and like every assumption, it has a domain of validity, a region where it works, and a boundary beyond which it stops working. The boundary of causality, of before and after, of the very concept of first. That boundary appears to be located somewhere in the first fraction of a second of the universe's existence. In conditions so extreme that the physics we have cannot describe them, and the concepts we use to build questions may not apply. Beyond that boundary, before the before, at the place where the word before loses its meaning, there is no answer to what came first. Not because the answer is hidden, not because we haven't looked hard enough, but because the question requires a framework that the universe had not yet assembled. The universe did not begin, not in the way the word begin implies. It arrived at a state from which a beginning was possible. And what was there before that state is not a mystery waiting to be solved. It may be a question waiting to be outgrown.